Hi, and welcome to this Math Day video on area of a regular polygon. We're going to start by deriving the formula, which I already have written here, is 1/2 AP, where A is the apothem and P is the perimeter. On a regular polygon, and all regular polygons, if you remember, can be inscribed in a circle, there's an apothem which goes to the midpoint and is perpendicular to one side. And they have a radius, because if the polygon is inscribed in a circle, I have this nondescript polygon here, for which we don't know the number of sides, so I haven't drawn the whole thing. So this is the radius, because it's the radius of the circle, which has the same center as the polygon. This is the apothem, and this is the length of one side down here, which I could call, say, y, and this, say, x, or whatever. So this is the basic terminology that we are working with. Now, if we look at this picture a little more closely, you can see that, of course, the radii will be equal. So this triangle right here that I'm highlighting a little bit is essentially an isosceles triangle. And the number of isosceles triangles, all of which are congruent to each other, is equal to the number of sides. There's one isosceles triangle for each side. So if we could find the area of one of those isosceles triangles, we could multiply it times n, which is the number of sides, because we know the area of a figure is equal to the sum of the areas of all of its non-overlapping parts. So our overall big idea in words is that the area of a regular polygon is equal to the area of one of the triangles times the number of equal triangles that there are. Notice we're saying a regular polygon here. So the area of a triangle we know to be 1/2 base times height. So for now I'm going to call it BH. And we're going to times that by n, the number of triangles, which is equal to the number of sides of the polygon. So let's change those variables to match the variables in our setup here. The base of the triangle is actually, in this case, y. And the height of the triangle is what is referred to as the apothem times the number of sides. Okay. Now, how do they get from that to the 1/2 AP? Well, I see the 1/2 and I see the A. I don't see the P. But if you think about the letter P representing perimeter, in fact, that y is the length of one side of the polygon, and n is the number of sides going around the polygon, y times n is actually the perimeter of the polygon. So that's how we get 1/2 times apothem times the perimeter. Now we can give all kinds of crazy different information for which to work with. You could know the apothem and the radius and have to find the side, and then the side and have to find the radius and the apothem. Actually, you don't really need the radius. But most of the time you're going to have to start by finding one of these angles here. Because if you know any one of the three of these, using a trigonometric ratio or function will get you the other one that you need to know. So if you know r, you'll have to find a and x to get y. And if you know a, you'll just need to find y. And if you know y or x, you'll just need to find a. But in any case, you're going to need that angle right there to do it with just a basic trig ratio. And we can easily get that by using the fact that there are n number of triangles going around the polygon, which have to add up to 360. So you can take 360 and divide it by the number of sides to get this red angle right here, and then just take that and divide it in half. So 360 over 2n will give you just the little angle in one of the right triangles. So let's put this to practice. I have a couple of examples here. Actually, I have 3 examples. So the first one, we have a regular decagon with a side length of 10 inches. I actually got a picture of a regular decagon. So if I look at that regular decagon, here's my triangle, which might be too tiny for me to work with in that picture. But I know I don't want to quit until I have the apothem and the perimeter. Well, if the side length is 10 inches, and it's a decagon, which means n equals 10, then the perimeter has to be 100 inches. So that's easy. Now we got to work to find the length of that apothem. Well, if I go from here all the way around, and that's 360 degrees, this triangle is 1/10 of that. So this angle through here is 1/10. 360 divided by 10 is 36. Then I have to take that 36-degree angle and split it between the two, meaning that this angle right here is 18 degrees. Now I'm going to pull out this right triangle, draw it bigger on the side so we can work with it. So here it is, exaggerated a little, where this is 18 degrees. And then this part down here is going to be 5, half of the 10. And I really need that apothem. So I'm going to work to get that. 18 degrees, 5 opposite over adjacent. We're looking at tangent. If I cross multiply, I have A tangent 18 equals 5. And so that means A equals 5 over tangent 18. I am ready for the calculator now. Let's do 5 divided by tangent of 18 degrees. Not showing up too well here. That's a little better. So I have, oh, no, list 5. That's not good. 5 divided by tangent 18, I get 15.4 approximately. So the apothem is approximately 15 point, I'm going to go to 4 decimal places. 3884. So that is 15.3884 inches times half. So that's what I got to type up here. So I have my 15.3884 times a half times 100. I get about 769.4 for the area. Inches squared. Keep note that 18 degrees, definitely not a special right triangle situation. Most people probably round that off to 770 approximately, or 769 if you're really going to round properly. All right, the other 2 examples. A regular octagon. Okay, octagon has 8 sides. So if I take 360 and divide it by 8, I get that this angle here is 45, which you might think, oh, it's a special right triangle situation. But no, really, because the angle we're looking at, just this part of it, is 22.5. A side length is 8 centimeters, which means this is 4. So to get my apothem, the tangent of 22.5 is equal to opposite over adjacent, 4 over A. So A is equal to 4 divided by tangent 22.5. 4 divided by tangent of 22.5, I get 9.6569. Okay, so that is the length of the apothem. I am now ready to get my area, 1/2 times 6569 centimeters, times the perimeter, which is, each side is 8. There's 8 sides. How original is that? 64. So here we go. It's a little better on this side. 1/2 times 9.6569 times, oh, there we go, times 64. Does that look, no, it's a times. And I got 309.02, so about 309. 309 centimeters squared. Now this last example, which I would encourage you to try on your own, does have a special rights situation. When I'm doing the hexagon here, one side length is 12 inches, so that means each part is 6 inches. And because there are 6 triangles going around, 360 divided by 6 is 60. And when you bisect that 60 degrees with this altitude right here, this isosceles triangle, you get this as 30. So if you think you can do this, it'd be a good time to pause the video, try it on your own, and come back. All right, let's check it out and see what we get. So if this is 6, then the long leg of this 30, 60, 90 is 6 roots of 3. So I'm ready to do my 1/2 times apothem times perimeter to get the area. The apothem is 6 roots of 3. And the perimeter is 12 times 6 sides going around, because one side is 12. Remember, you're doing the perimeter of the entire polygon, not the perimeter of one of the triangles. So 12 times 6 is the perimeter of the entire thing. 12 times 6, the perimeter is 72. I'm going to take that and multiply it by 6 and multiply it by 0.5. I'm multiplying everything except for the square root of 3, so I can leave it in simplest radical form. So I have 216 roots of 3 inches squared. Now, just to give a decimal approximation, I get about 374.1. And that is how you use the area for a regular polygon formula.